Hi friends, welcome to this class. In this video, we are going to discuss about this cyclic silicons, right? So what are the cyclic silicons? Sorry, cyclic silicates. These are nothing but the silicates. That is, anion will form a cyclic like structure, right? And they will have this general formula which I have written on the screen. That is SiO3n 2n minus, right? So that will be the general formula. See, SiO3n 2n minus, right? So here n is nothing but number of silicon atoms, right? So it will form different cyclic structures. For example, see, if n is equal to 3, then what I will get? SiO3 3 times 2 into 3, it is minus, right? So it will be Si3O9 6 minus, or minus 6 I can write. So this will be the formula. So this is anion, right? So this we call it as anion because it is having negative charge. That will form cyclic structure. For example, see here. Let me draw the silicon atoms like this. So this is my silicon atom, right? So with yellow marker I am drawing it. And these are oxygen. One oxygen will be above, other oxygen here, other oxygen here, and other oxygen here, right? Negative charge I will leave it later, right? So there will be bond like this. Let me take one more color. So it will be like this. See, that is again attached to one more silicon, right? So one oxygen, two oxygen, three oxygen, and this one is fourth oxygen, right? Similarly, I can again this oxygen is again attached to one more silicon like this, right? So that will be having again four oxygens. One oxygen, this will be two oxygen, this is three oxygen, and this one is four oxygen, right? So here, if you see, I have made up this with three of the orthosilicates, right? So you can do like that. And also, if you see here with red marker, let me show. See, this is one unit, right? So because it has got one silicon atom and four oxygen, two of its oxygens are common to other silicon also, right? So this is silicon atom, other silicon, right? I have told it, this represent, this is silicon, whereas this circle represent, this is oxygen, right? So this is how it will form. So if you see the structure, it is like what? Cyclic structure, right? So this anion part will do this cyclic structure. So if I remove all those things, then what happens? Sorry, okay, just we shall do some things, right? So let me draw it again so that it will be clear to you. So it will be like silicon attached to four oxygen, right? So one oxygen, two oxygen, three oxygen, and four oxygen, right? So again, this oxygen is attached to one more silicon. So one oxygen, two oxygen, three oxygen, and this one is the fourth oxygen. Similarly, silicon, oxygen, like this, right? So it is from this charge. If I want to give the charge of it, so this oxygen is bonded to only silicon. So one bond means other bond will not be there. So it gets negative charge. So it will also get negative charge. So it will also get negative charge. And these oxygens won't get negative charge because they are bonded to two silicons. Two bonds are there. So no negative charge. And this oxygen, which is attached to only silicon, that will also get negative charge, right? So what is the formula? If you count how many number of silicons we have? Si, one silicon here, two, and this is three. Si3 oxygen. Count just 1, 2, 3, 4, 5, 6, 7, 8, 9. Si3O9. Charge, if you count red markers, 1, 2, 3, 4, 5, and 6. So 6 minus negative charge. So this is the anion part. And to that there will be cations, different cations, and they will form this cyclic silicates, right? The cations may be calcium, right? Barium, so many things. Sodiums are there, right? So beryllium, those will be the cations, right? Similarly, so what was the formula? The formula was SiO3n 2n, right? Minus 2n or 2n minus, however you want, you can. So for n is equal to 3, we saw this one for n is equal to 3. Now let us see for n is equal to 6. So what happens if n is equal to 6? What I will get? SiO3 6 minus 2 into 6 is nothing but minus 12. So its formula is almost Si6 O 6 3s are 18. So it is 12 minus or minus 12. So this is the general formula I will get. So what will be its structure, that we shall see now, right? So if I want to give the structure, so this is my silicon atom, right? Oxygens, let me show it by blue now. Oxygen, 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 and oxygen, right? So other positions also I'll keep it like this: oxygen here, one more oxygen here, again here one more oxygen, oxygen, right? So again I will keep silicon here. See, 6 silicons I want. So one silicon, yellow marker means one silicon, this is second silicon, this is third silicon, this is fourth silicon, this is fifth silicon, and this is sixth silicon, right? Let me do it nicely. This is sixth silicon, right? So one unit will have, we having 4 oxygens, right? So this is one oxygen, second oxygen, third oxygen, fourth oxygen. For this silicon also 4 oxygen, 1 2 3 4, right? So for this 1 2 3 and 4. For this 1 2 3 and 4. For this 1 2 3 and 4. For this 1 2 3 and 4, right? So see how nicely the structure became. And if you see this structure, it will be having cyclic structure, because of which these are called cyclic silicates, right? So if I want to give the charge, so negative to this, negative to this, negative to this, negative, 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 right? Negative and negative. And the oxygens which are bonded by two atoms, they won't get negative charge. The reason I have explained so many times, so no need to now, right? So if you count the silicon atom, so here we have 6 silicon atom, Si6. If you count oxygen, let me count it by this marker. See here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 18. Okay, so this will be Si6 O18, sorry, Si6 O18, right? O18. If you count the negative charge, each is having two, here two negative charge, 2 4 6 8 10 and 12, minus 12. So we had planned the same thing, right? So we got the same, right? So this is what we have got, and its structure is like this, right? So and I have told, whenever you do the structure like this, if this is the structure, later you need to join it like this, right? Because this is how they will give in the textbooks, right? So every time when I do, I have to do like that, right? So let us do again, so that it will be clear to you also, right? So how it will be? So I told, silicon atom, for that 4 oxygens totally, right? Here 4, and this is one more silicon, here one more silicon, and 4 oxygen, right? So how I should do? I should do like this, right? So this is how I should do: oxygen, oxygen, but here no oxygen oxygen bond is there, but in books they will give like this. And negative charge, if you want to show, you can place negative charge on oxygens, on which oxygens negative charge exist, you will know that, right? So this is what, this is the formula of Si3O9 6 minus, right? 246, yeah, this is the structure. And one more for Si6, how it is? So silicon is there, to that one oxygen, second oxygen, third oxygen, right? And here one oxygen, right? So silicon like this. I hope now it's clear to you how to draw all the structures, right? Sorry, just draw it like this, right? Wow, so beautifully it happened, right? Further, how we will add? Just see, this oxygen, this oxygen, this oxygen, this oxygen, this right? This is how it will happen. How nicely we can draw. So this is how they will give in book. You will feel, sir, what is this, sir? How it looks complicated, how to draw like that. But now, after seeing this, you can easily draw it, right? Because this is how we should learn. So this is how it happened, right? So this is the structure. Negative charge you can give this negative, 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 and negative, right? So if you count, it will be like size 6, O18, right? O18, 12 minus. I got O18, right? Yeah, O18. And this one is SI, one more SI3O9. Yes. Yeah, both formula are correct. So this is Si3O9 6 minus, and this is Si3O18 12 minus, right? So I hope the structures and the things are clear, right? So so these anions parts, I have always told you, this anion part is there, right? That will determine the structure. So it can be orthosilicate, pyrosilicate, right? And this is cyclic silicate. The only anion part will decide. And corresponding cations will be there to form the compound. For example, let us see few examples so that you will appreciate it. So let me give. This is benito benitoite, right? So it is nothing but barium, titanium, trisilicate. I'll give you the formula. So barium and titanium are the cations here, right? So what will be the formula? Barium, titanium, Si3O9, right? So Si3 means here N is nothing but 3. So this is the example for this cyclic silicate in which N, that is 3 silicon atoms are there, right? So barium, titanium, trisilicate, we call it as benitoite. Benitoite. This is how you should. Ah, I don't know whether I am pronouncing it correctly or not. You should, right? Just remember any two so that you can reproduce it in any of the exams. This is LS2 night. Second example, LS2 night. That is nothing but calcium trisilicate. See here, metal is calcium. So Ca3 is there and silicate Si3O9. Because we know that, because 3 silicate means 3 of calcium is plus 2, means total 3 to the plus 6, and this charge is 6 minus, so both plus 6 minus 6, so it will become neutral and it will form this structure, calcium si- uh, trisilicate, we call it as wollastonite. Wollastonite, right? Let us see one more example, that is cataplite. Cataplite, Catapleit. This is Pleit, cataplite. So that is nothing but sodium zirconium trisilicate, right? So trisilicate means, and there will be water of hydration. So two molecules of there. So water of hydration, hydrate I can call. Sodium zirconium trisilicate hydrate. So the formula is like Na2Zr Si3O9, two molecules of water, H2O. So hydrate, water of hydration we call, right? So sodium is there, zirconium is there, and this is trisilicate. One more thing I forgot to tell. If Si3O9 6 minus is there, then we call it as trisilicate. Trisilicate, or you can call like cyclic form is there, right? Cyclic silicate also you can call, because it will form cyclic structure, right? A ring like structure it will form. So since what tri means, 3 silicons are there, so we call it as tri. If we have the formula like Si6O18 12 minus, so how many silicons are there? 6 silicons, so we call it as hexa silicate, or we can also call it as hexa cyclic silicate, right? You should understand, right? So the above, the structure which we have discussed, right? So this structure is nothing but trisilicate structure, and this structure is nothing but hexasilicate, right? Just you remember, I didn't give you the name, but just you can do now, right? So these are the things. I hope you understood. Let us see example for this hexatrisilicate. One example. So that is beryl. Beryl. So beryl is nothing but it contains the metal is beryllium. Along with that, aluminum is there, right? And it is hexasilicate. Hexacyclic silicate or hexasilicate. So the formula, if you see, it is Be3Al2 Si6O18. So because this anion part is nothing but Si6O18 12 minus, right? So here we should have 12 plus. So 12 plus, how I'll get? Aluminum is plus 3, right? So 2 into plus 3 because 2 aluminums are there. Plus beryllium 3 into plus 2. Beryllium charge will be plus 2. So here 3 to the 6 plus 3 to the 6. So it is nothing but plus 12. So plus 12 here and 12 minus here. So it will form a compound, neutral compound, that is nothing but this one, Be3Al2Si6O18. So beryl we call it is, right? So these are the few examples, right? So these are the minerals, right? This is how they will exist in the soil, earth, earth crust, right? So this is about cyclic silicate. In next class, let us discuss about chain silicate.